Right, so we're going to look at some directing group problems now when we're trying substituting on the benzene ring. So here are two little compounds that we are going to try and synthesize starting from benzene. So the first one we will look at is we'll look at this top one here, and we'll notice the difference that we need to do when we try and synthesize the second one here. So let's look at this guy. Okay, so let's have a look at this one first of all. I'm going to make this compound and I'm going to start from benzene. If, say, for example, I introduce the chlorine first, a chlorine group is electron releasing, and so if I pop on this boy first, he will then direct further groups to the 2, 4, and the 6 position, which I don't want because I want to introduce that NH2 group onto the 3 position. So I don't want to introduce the chlorine first, so I'm going to introduce a nitro group first. The nitro group is electron withdrawing, and a nitro group instead will direct groups onto the 3 and the 5 position there. So let's do that. In order to introduce a nitro group, as you know, we use concentrated nitric acid, concentrated sulfuric acid, and we're going to heat it at 50 degrees. And that will pop a nitro group on like so. Once I've got that nitro group on, I'm going to react it with chlorine, with an iron trichloride catalyst. That will then introduce a chloro group. And as I said, because the nitro group is electron withdrawing, it directs groups to this position and this position, hence being able to produce a chlorine there. And then finally, to get to that product there, I need to reduce that nitro group down. And as you know, that I use tin in concentrated hydrochloric acid and I reflux it. Okay, so now I need to make this molecule, and you can see I've shifted the chlorine there in relation to the NH2 group. So how can I do that? Well, again, if I introduce the chlorine first, we said chlorine is electron releasing, and so we'll direct groups into that position, and that position there. So I can certainly do that one. So let's do that. So first of all, I'm going to react it with chlorine with an iron trichloride catalyst to give me a chloro group there. Then I'm going to react it with concentrated nitric acid, concentrated sulfuric acid, and that will pop on a nitro group into that position there. And then finally, I'm going to reduce that using tin in concentrated HCl and reflux to change that NO2 group into an NH2 group. So hopefully you can see the importance of putting your substitutes on in the correct order when you want to do a synthetic route involving benzene and directing groups.